Hi, my name is Alfonso Campos, and today we explain the report for how to use the PASCO capstone software. Okay, so this practice was in order to learn how the PASCO software can be used and applied to some experiments. First of all, we were teach how to import data. They give us some voltage right here on the y-axis, again some time, well, a table with the voltage and the time data, and by using the PASCO software we could import this data as a zip file and get a graph which of voltage versus time, and as you can see here is the graph that is being represented. Then we learn how to use the tool that tells you the best fit line that you choose. For this one, we specifically choose the one for the natural exponential, which will be this formula right here. And as you can see, it tells us both the values for each of its variables, in this case a, b, and y0, as well as its uncertainties, which is the deviation from the in quote a perfect value, as well as the RMSE. As you can see here, because it is very close, it cannot almost be seen, but as you can see here is the exact graph of this formula right here. So this could be very useful in order to make some experiments which require you to get the best fit line, especially for some complicated ones like this one right here. Then we use the calculator tool in order to make the voltage, instead of having the voltage by itself, we took the natural logarithm of the data we gave and then graphed that. As you can see here, because the previous one was exponential, here it should be linear. As you can see, it is linear. It may be not perfect, but here you can see the perfect line. And it also tells us this. So with this tool, we could also apply some calculation to a variable, like squaring it or taking the natural logarithm, etc., in order to get a more precise graph, specifically a linear one. And finally, we made this circuit right here in order to prove this formula right here of voltage equal to initial voltage times 1 minus e to the minus time divided by tau. So we will know the voltage at any moment, as well as the time. And by using the tools we learned, we will graph them and get an approximate value of the initial voltage and tau. This was done by making a self-made function that is this formula right here, and see the closest values. And as you can see, here's the experiment, and it worked. We got the PASCO software uploaded in real time, both the time and the voltage, and as well as after some analysis of just this area right here, we could get an approximate B0 and tau. Sadly, we weren't able to make this perfectly. As you can see here, we couldn't make it so that it didn't, the best fit graph didn't pass 0, 0. If it didn't pass, it would be even closer than this, but as you can see, it was also really close. So therefore, we learned how to use the most important features on the PASCO software. Thank you for watching.